In order to take advantage of DynamoDB capabilities, it is recommended that you use the single table model. At a high level, a single table model involves using a single DynamoDB table to fulfill needs of your application or microservice. In this lesson, you will learn the basics of single table design and why should you not use multiple tables. I'll start this lesson with a question. Can you use DynamoDB like an RDBMS? That is, have separate table for each entity? Technically, the answer is yes. Using DynamoDB like an RDBMS is the most common beginner mistake I have seen, especially when the engineers who are involved in the project are new to DynamoDB and involved in lift and shift of existing applications. As you already know, there is no join capability in DynamoDB, and that translates to doing a join on the application end. In this banking app example, I'm showing three tables: customer, account, and transactions. Customer profile page requires information on customer, their account, and the last 10 transactions in the account. Now, in order for the application to create a customer profile page with the data from all three tables, app will need to first get the data from each of the tables and then join it to make it meaningful from the application perspective. As you can see, there are three calls that the app needs to make, and then it needs to carry out a join. This is going to be inefficient and will lead to suboptimal performance. And that is just one reason why traditional RDBMS design principles don't apply to DynamoDB. Apart from that, the main reason you should not use DynamoDB like RDBMS is that it is not meant to be used like that. DynamoDB gives great performance and scalability as a result of data model that leads to pre-joined data. In other words, if you're using DynamoDB like an RDBMS from the get-go, then you're not taking advantage of Dynamo's capabilities. Another reason is that using multiple tables may not be cost effective, as each table would require capacity to be managed independently. Since the capacity is not shared between the tables, overall the idle capacity will be higher than it would be compared to a single table. Your tables will not get the advantage of mechanisms like adaptive capacity and burst capacity, which translates to lost potential savings. Having multiple tables instead of a single table will lead to an increase in operational and maintenance overheads. For example, in the banking application I described, instead of monitoring a single DynamoDB table, developers will need to monitor 3 DynamoDB tables. Also, there is a limit on the maximum number of tables in a region. Last but not the least, more data and unique entities in a single table means larger is the spread of data across a higher number of partitions, and that translates into better performance. Objective of the single table design is to minimize the number of queries to the database. Best if you could get all the required data with a single query. But the biggest hurdle to achieve that objective is that DynamoDB does not support joins that are a core capability in an RDBMS. You already know that data in DynamoDB is managed in partitions with B trees. Pre-joined data is what leads to DynamoDB's high and consistent performance at scale. But pre-joining of data requires that you know the access patterns in advance. For example, the banking app needs customer profile, which consists of customer information, account info, and last 10 transactions for the account. Another access pattern may be for pulling the transactions for an account based on a date range. Since same data may be needed via multiple access patterns or queries, it may not be possible to manage the data in normalized fashion, which translates to data duplication across multiple entities within the table. For example, customer name may be duplicated in the customer and account entities to fulfill needs of account-related access patterns. As you know, that a table can have a single key, which may be a partition key or a composite key with partition key and sort key. You can query the table only with the key attributes, but your access patterns will need queries on non-key attributes, which means that you will need to define indexes. And since there is a limit on the number of indexes that you can create on a table, it is important to design the indexes in such a way as to minimize the number of indexes, which, by the way, leads to cost efficiencies as well. You need to apply the proven single table design patterns to achieve the desired results. As a best practice, use single table design for your DynamoDB applications. As an architect, it will be your responsibility to decide between single table and multiple table model. It is highly recommended that you learn the single table modeling technique so as to be in a position to guide the development teams on the right way of using DynamoDB. Happy learning, and I'll see you in the next lesson.